Hi guys, this is video number 2, and we are wrapping up the relations and functions. This was just restating what we had before, where you are function is a relation in which each element of the domain is paired with exactly one element of the range. So right here you've got -3 goes to 0. Your domain here would be -3. The range for this one would be the 0. The next point, you've got 4 going to -2, so 4 and -2 will be your domain and range. And the last point is 2 going to -6, so 2 is your domain, -6 is your range. Each of these domain members has only one y member, so this would be a function. This right here, you have your domain. This 4 is going to a -2, so you have 4 and -2. Then this 4 is going to +2, so you've got a 4 right here again, only this time it's going to a +2. You can keep going as far as your domain members and your range, but right now it has already been decided that it is not a function because you've got two different 4s, and they're going to, the same 4, going to two different members of the range. So this is another way to state it. A function is a set of ordered pairs in which no two pairs have the same first element. So these two pairs have the same first element, so it is not a function, just like we did in the last video. All right, right here, this is trying to show domain and range. The domain is composed of the values of the independent variable. This is going to be important, especially later in the next unit when we have to deal with compositions. The independent variable means it does not depend on what you put in. You can choose whatever you like here. The y, however, that depends on what x is. Okay, it doesn't have a value by itself. It depends on what x value you put in and what comes out of that. That's why it's called dependent. Okay, with continuous functions, you have domain and range intervals. And the domain is always from the smallest point to the largest along the x-axis. Okay, so it will always be set up, small point to the x to the large point. Now, whether or not it has an open circle or a closed circle depends on whether it is an equal sign or not. Both of these are colored in, so they would both have equal signs. The range is always looking along the y-axis. Oop, had a little error there. When you're looking at the graph, the interval will be from the smallest point to the largest point. So, this is actually the smallest point. It's not the end point, but it's the smallest point. And it's always set up the small with the y in the middle up to the largest point. And right here is the largest point, even though it's not an end point. Okay, but that's the high point and the low point. And that's what you come up with for your range. So when you've got a graph that looks like this and you want to graph with the domain, you want to find out what the domain and range is, you go from the smallest point, which is a -5. Remember I told you the x would be in the middle because it's along the x-axis. And 7 is the large point. These are open circles, so you would not have an equal sign underneath there. For your range, you'd have a low point of -6 and a high point of 8. Now this point right here, there is no hole in the graph, so it's colored in. You'd have an equal sign. This one, however, has an open circle at the 8, so it would be just a less than sign, no equal to. All right, so here are some examples for you. And right here, your domain value would go from -4 up to 6. Your range value would go from -2, low point, up to 7. Okay. This one, low point is -6. High point is 5. For your range on the Y value, the low point is -3. And the high point is 5. This was a little tricky. People tend to want to go with the end point, but that's not the highest point. The highest point is here. Okay. So our domain works like it always does. This is the low point, -3, up to the largest point, 4, and they're both colored in. The range here is from -5 up to +5. And this one's very basic again. It is open circle everywhere except here. So you go from -5. I think we just did this one on the last slide, didn't we? We did. This was from the last slide. Okay. State the domain. Now, in these are the only things that actually limit a domain. And that because it has a denominator, that's why your domain gets limited. You cannot have a 0 on the bottom of a fraction. Makes it undefined. So that's why you set this equal to 0, x squared minus 4x equals 0. Factor that out. So this times this equals 0. Either x equals 0 or x minus 4 equals 0. So you've got x equals 4. What that means is, and I usually put a not equal sign there, because it means that x cannot equal 0 or x cannot equal 4. And that would make your domain. You would put your domain is all real numbers, and that's how you write all real numbers in a symbol, 2 bars, and then just write the R. X cannot equal 0 or 4. Now here, a square root anyway cannot be negative. Okay? Not yet anyway. We haven't got complex numbers. So you would always set that up so that it would have to be positive. And that's what you're going to have to do here, because it can't equal 0 and it can't equal 0. Can't equal negative. This, if it's on top, can equal a 0. It cannot down here. So square root of x minus 4 must be greater than 0. Cannot even be equal to. So you're going to square both sides to solve this. And x minus 4 must be greater than 0. Take that over and x must be greater than 4. So that's what you would have for your domain here. Okay, let's start right up. Oh, big R. Okay, your domain here, you could say that you can put all real numbers, but x must be greater than 4. Most people just write this one right there. X is greater than 4. Okay. Quick little review of your function notation. When you have f of x equals this, that x value right there is what went in here, here, and here. That's your x. When they say f of -4, that means the -4 goes in everywhere you have an x. Okay? So, 3 -4 cubed minus 7 -4 squared minus 2 times negative 4. You can easily put that into a calculator. Same thing here. The g of x, and it fits in exactly where the x is. So when you have a g of 9, your 9 goes in right there. 6 times 9 minus 77. That is 54 minus 77, which is how they get the negative 23, or absolute value of that is a positive 23. Okay. They can also be evaluated for another variable. So this right here is just changing it from an x to an a. So instead of it being 3x to the 7th, it's now 3a to the 7th. And this right here, j of c minus 5, will be c minus 5 squared, just like that, minus 7 times c minus 5 plus 4. And you have to multiply that out. That's c minus 5 times c minus 5, which is c squared minus 10c plus 25. That's where they get that right there. Negative 7c and positive 35 plus 4. And then you combine your like terms. I have a negative 10c and a negative 7c, which gives me negative 17. And a 25, a 35 is 64. So combine like terms. We're going to do a more thorough review of your functions later, but that's just quick so you would kind of draw it back up in your mind as to what you'd seen before. So let me know if you have any questions.